You've seen the headlines, right? One day coffee's gonna save your life, the next day it's bad for you. It feels like everything is connected to everything else. But what if I told you that most of those connections you read about, they're just an illusion? Well, today, we're gonna build a toolkit to help you see right through the noise and figure out what those science headlines are really trying to tell you.
All right, let's kick things off with a little puzzle. It is a fact that when ice cream sales go up, so do the number of drowning deaths. Seriously, if you put them on a graph, the two lines would look almost identical. As one climbs, the other one follows right along with it. The correlation is crystal clear. I mean, it sounds completely ridiculous when you say it out loud, doesn't it? But if you just look at the numbers, you can see a clear link. This is the exact kind of statistical trap that news headlines and, let's be honest, our own brains can fall into. So let's figure this out. And here we go. This is it. This is the single most important rule for this entire explainer. Just because two things move together, it absolutely does not mean that one is causing the other. This mistake is so common it actually has a fancy Latin name. Cum hoc ergo propter hoc. It just means, with this, therefore because of this. It's one of the oldest logical fallacies in the book. So, if A isn't causing B, then what in the world is going on? Well, there are basically three major ways that a correlation can fool us. First, you could have the whole thing backwards. Maybe B is actually causing A. We call that reverse causation. Second, it could just be a total fluke, sheer coincidence. But the most common and honestly the trickiest one is the third one, a hidden factor, some C that's secretly pulling the strings on both A and B. This is a perfect and kind of gross example of getting it backwards. Back in the Middle Ages, people noticed something weird. Healthy people often had lice, but when people got sick, the lice disappeared. So their conclusion, lice must keep you healthy. Of course, the reality was the complete opposite. Lice hate heat. When a person got a fever, the lice would just pack up and leave. The fever caused the lice to flee, not the other way around. Okay, let's try another one. This is a classic. It is a statistical fact that sleeping with your shoes on is strongly correlated with waking up with a killer headache. You can observe this. The data is there. So just think about that for a second. Is there some weird nerve in your foot that triggers a migraine if you leave your boots on? Is it the smell of the leather? Come on, what could possibly be linking these two things? There has to be something else going on. And there it is, the hidden player. Going to bed drunk is a pretty reliable way to do two things: fall asleep without taking your shoes off, and wake up with a nasty headache. It's the one common cause that explains the whole thing, and it's the perfect intro to what we're going to get into next. In the world of science, this hidden player has a technical name. It's called a confounder. And for scientists, especially the ones who study public health, hunting down and dealing with confounders is a huge part of their job. It's not just a fun brain teaser, it's a constant challenge, because in the real world, things are messy. So here's the official definition. A confounder is something that's linked to both the thing you're studying, the exposure, and the thing you're measuring, the outcome. In our first example, hot weather is the confounder. It makes people eat more ice cream, the exposure, and it makes more people go swimming, which leads to more drownings, the outcome. The confounder is the puppet master creating a fake link between the other two. This little diagram shows it all. You see a connection between E, the exposure, and D, the disease. So you think, E causes D. But wait, look up top. You've got U, the unmeasured confounder, and you see it has arrows pointing to both E and D. That means it's the real cause behind both of them. If you don't account for U, you're going to get the story completely wrong. Okay, let's bring this into the real world with something you may have actually seen online. There's been a lot of discussion about a possible link between taking acetaminophen, that's the active ingredient in Tylenol, during pregnancy and a higher risk of autism or ADHD in children. And for any parent-to-be, that's a really scary and confusing headline to see. So this is where we need to put on our scientist hat. Why do people take acetaminophen? Well, they don't just take it for fun. They're usually trying to treat something, like a bad fever or an infection. And we already know that having a high fever or certain illnesses during pregnancy can be a risk factor for a developing baby. So the big question is the link with the drug itself? Or is it with the reason the drug was taken? That underlying illness is a huge potential confounder. So how do scientists actually solve these mysteries? How do they get past these misleading correlations and find out what's really going on? Well, it's tough, but they've got some powerful methods. And one of the most brilliant examples comes from way back in the 1850s, in the middle of London. This is a quote from Dr. John Snow. He was investigating a horrific cholera outbreak, and he realized that London had accidentally set up a perfect natural experiment. You had two different water companies supplying water to the exact same neighborhoods. I mean, houses right next to each other had different water. One company was pulling its water from a part of the river that was full of sewage. The other was getting it from a cleaner source upstream. And the data he found was just, wow. Take a look. The houses getting water from the Southwark and Vauxhall Company, the one with the dirty water, had a death rate of 315 per 10,000. The houses getting water from the Lambeth Company, just 37. That is nearly 9 times higher. It was a smoking gun. Because everything else about the people was the same, Snow could confidently say the water was the cause. Now, John Snow's story is amazing because it's so clean, so clear-cut. But we need a reality check here. Most modern science just isn't like that. Most of what we read about comes from observational studies, where scientists are just watching people live their lives. They're not running a perfect experiment, and that makes finding true causes a whole lot messier. This quote might sound pretty cynical, but it comes from a deep understanding of how hard this research is. In an observational study, it is almost impossible to control for every single potential confounder. Things like diet, exercise, income, genetics, everything. And because of that, these studies often produce findings that just don't hold up later. And that brings us to another huge point, the size of the effect. A lot of these big, scary headlines are based on studies that find a really weak link between two things, say something that increases your risk by less than double. That's a small effect. And as you can see here, a small effect can easily be just statistical illusion caused by bias or confounder. It's not like the 9 times bigger risk John Snow found. An effect that small could just be noise. Okay, so we've looked at the problem, we've seen all the traps. Now for the fun part. Let's take everything we've learned and build that toolkit I promised. We're going to boil it all down to a few simple questions that will give you the power to read these headlines like a scientist. So let's jump back to that real-world acetaminophen example. This is exactly the kind of thing you'd see on a parenting forum. A person is genuinely concerned. They've seen a scary headline, and now they're trying to figure out what to do, how to balance the risks. It's a tough spot to be in. Here it is, your new mental checklist. Anytime you see a health headline, just run it through these 4 questions. Number 1, is this just a correlation? Number 2, could they have it backwards? Number 3, this is the big one, what's the hidden player? What's the most obvious confounder here? And number 4, how big is the claim? Is this a Jon Snow level effect, or is it so small it could just be bias? And if we apply that toolkit to the acetaminophen issue, the picture gets a lot clearer. The big potential confounder is the illness that prompted someone to take the drug in the first place, especially a fever. And here's the crucial point. An untreated high fever during pregnancy is a known, documented risk to the fetus. So avoiding a medication because of a weak, uncertain association might actually lead someone to accept a much bigger, more certain risk. So from now on, when you see that headline that says X causes Y, you'll be ready. You have the tools. You don't have to just accept it or dismiss it. You can start asking better questions. And maybe the most powerful question to start with is always, okay, but what's the hidden player here? Thanks for joining me.